Hello everyone, welcome to the session of the course Data Analytics. Now we start learning model building and its verification and validation. So let me clear what is model building. Model building is the process of developing a probabilistic model. Purpose of building is to refining and testing the model. One important point is that using regression analysis, for example linear regression, it will help us to answer which factor is having a significant impact on desired or expected outcome. So this we will discuss in brief very soon. Before that, we will see the contents of today's session. In today's lecture, we plan to learn about basics of regression analysis. Then we will learn about error estimation in regression. Then we will proceed to learn about simple linear regression. And in the last, we will solve one example based on linear regression. So dear student, this is the pathway for our lecture. Next, we will see what is the regression analysis. Regression analysis is primarily used for two distinct purposes. First, it is widely used for prediction and forecasting, which overlaps with the field of machine learning. Second, it is also used to find the causal relationships between independent and dependent variable. In statistical modeling, regression analysis is a set of statistical processes for estimating the relationship between a dependent variable called outcome variable and one or more independent variable, often called predictors or covariators or features. The terminology associated with the regression analysis are dependent variable or target variable, which is nothing but a variable to predict, or response variable, also known as regress output variable. It is generally denoted by Y. Then the second term is independent variable or predictor variable. Variable to estimate the dependent variable, also known as regressor or explanatory variable. It is an input variable, generally denoted by letter X. Then one more important term is that there will be an outlier. Observations that differs significantly from other observation, it should be avoided since it may hamper the results. To get rid from the data points, that is outliers, we need to redo the process to observe the bad data points and then remove it. Next, we will see what does regression analysis do. Regression analysis produces a regression equation where the coefficients represent the relationship between each independent variable and the dependent variable. In other words, it is examining whether the changes or differences in values of one variable, that is a dependent variable Y, and linked to changes or differences in value of one or more other variable, that is independent variables such as x1, x2, while controlling the changes in values of all x's. For example, the relationship between salary and gender for people who have the same level of education, work experience, position, seniority. So there will be a certain relationship between salary and gender. So the dependent variable Y must be a metric in nature, that is covariance of or you can say metric variable is a variable measured quantitatively. For example, the distance between the values. Then independent variable, that is x, must be either metric or dummy variable. A dummy independent variable, also called as dummy explanatory variable, which for some observation has a value of 0, that cause variable coefficient to have no role in influencing the dependent variable. While when the dummy variable takes a value 1, its coefficient act to alter the intercept on y-axis. A dummy variable is indicate the absence or presence of some categorical effect that may expected to shift the outcome categories. You can take one example such as smoker or non-smoker. The dummy variable can signify the differences. More specifically, do the values of y tend to increase or decrease as value of x1 and x2 increase or decrease? If so, by how much, and how strong is the connection between the relationship between x and y? What percentage of difference or variation in y values, for example income, among study subject, can be explained by attribute to difference in x values? For example, year of education, year of experience. If y cap appears above the variable, then probably represent sample statistics. Without little hat, only y refers to observed value of y in the data set used to calculate the regression equation. Hope you understand what does regression analysis do. Next, we will see the error estimation. Once we can determine how values of y change as function of values of x1, x2, we will also be able to predict or estimate the value of y from specific values of x1 and x2. The general equation is that the y hat a plus b1 x1 plus b2 x2 plus b3 x3 up to bk xk with error term epsilon. This epsilon is a error or residual term. So this is the equation for multiple variable linear equation. While in simple linear equation, this b2, b3 and bk xk, these variables are not present, but the error term or the residual term epsilon is present. In this regression equation, y is the value of dependent variable, what is being predicted or explained. Then a is constant that equals to the value of y when x is equal to 0. If we put x is equal to 0, then the rest of the term will be considered as 0. So y will be a. After that, variable b, it is the coefficient of x. Here you see that it is suffixed with x. So it is a coefficient of x. It is also known as the slope of the regression line. How much y changes for each one unit change in x. In short, it is an intercept term considered as slope parameter. These parameters are usually called as regression coefficient. Then you know very well that is x is the value of independent variable x, what is predicting or expecting the value of y. So here we can focus on the term epsilon, that is the error term. Error in predicting the value of y. Given the value of x, generally it is not displayed in most of the regression equation. The error accounts for an failure of data to lie on the straight line and represent the difference between the true and the observed realization of y. There can be several reasons for such differences. For example, variable may be qualitative, like color of a ball, for example red, green, blue, or inherent randomness in the observation. That is, difficult to find unique pattern in given data set. Therefore, regression analysis in a sense is about estimating the value of y using the information about the value of x. Estimation by definition involve the objective to minimize the error in estimation. This increase the accuracy of prediction or to compute estimate that are as close to the true value or actual values as possible. We wish to achieve maximum precision. We will discuss more about error estimation very soon. Before that, let's see one problem. So next, what is the simplest way to obtain an estimate for some population characteristics? For example, number of credit cards per US household. So the steps for solving such problem: select a sample from a population, compute the mean for the sample. So that is the general notation for the mean is x bar, and we are picking a sample from the data set. Then we compute the average number of credit cards for sample household. Then we compute regression analysis, that can be viewed as a technique that often significantly improves the accuracy of estimation result relative to using the mean value. So suppose we are estimating the number of credit cards for US household based on the information from a random sample. Suppose say n is equal to 8 families we have selected as a sample data set. For estimating the number of credit card, we need to calculate the mean of the responses. So here you know very well how to calculate the mean, that is the average, and to calculate the mean we are just taking the sum of all the credit card and divided by the count of family. So the sum of total number of credit card will be 56, and we have selected the sample, that is 8. So the estimation is 7. So that is the when we are representing the average value or the mean value, the notation is y bar. So y bar is equal to 7. So next we will can we determine how much error in estimation we are committed by using our estimation, that we will see on next slide. So to calculate the error in estimation, we subtract the value of obtained from estimate for number of credit cards, that is 7, from each value of actual number of credit cards. So 4 minus 7, that will be the error in estimation. So next we will see how much error is present in estimation. So here for the family number 1, the error in estimation is minus 3. So what exactly it indicate? In regression, an error is not a mistake. Note that it is a variability. It is in inherent part of the measurement process. So error in estimation represent the average distance that the observed value to the theoretical value of the data set, or somehow we can say it is the average distance between the estimated value and the true value of actual credit cards, which is nothing but our quantity of interest. In regression analysis, the distinction concept is most important, which is sometimes called regression residual. It is called regression residual. Smaller value are better because it indicates that the observations are closer to the fitted line. Let's now see all these graphically. You know that our estimation error is 7. So it intercepts on the axis of number of actual credit card at point 7. We are indicating our estimated line with a green line. You can also know that our F1, F2, F8 are our sample population. On next slide, you will observe the estimation error between the actual credit card and estimated credit card per household in US population sample. So let's spread the dots away from each other to see things more clearly. If you keenly observe that family 1 from our sample data actually 4 credit cards, while estimated value is 7. Similarly, family 2 actually hold 6 credit card and its estimated value is 7. So can we determine the total estimation error for all 8 families? So red dots shows the actual value while the green dot shows the estimate value. From the graphical representation as well as from this table, it is clear that difference between the observed value and the average value, which we will call the residual or error in estimation, produces negative sign to our weight. To increase the accuracy in prediction, we need to remove this negative sign, so that the remedy for that one, the squaring is necessary to remove any negative sign. It is also gives more weight to larger differences. It is called mean squared error. On next slide, we will see more detail about the sum of the square total, that is the SST. You may be wondering what all of those sum of square are. Well, they are the determinants of good linear regression. Determinants means a influence factor which affect the output or nature of the baseline or the outcome. There are few important terms in linear regression that we must understand clearly, such as sum of square total, sum of square error. First, we will see what is SST, but before that, if you keenly observe, if we put all these negative sign as it is, then what will happen? They will be cancelled out and produces 0 result. So we have taken the square term. So the sum of the square total is 22. The sum of square total, generally abbreviated as SST, is square difference between the observed dependent variable and its mean. You can think of this as the distribution of the observed variable around the mean, much like the variance in statistics. It is a measure of the total variability of data set. So just now we have calculated our index for a total combined amount of estimation error for all families observations in the sample when using the mean as the estimate. SST is also the sum of squared deviation from the mean, which is the contribution of factor into the variance of the dependent variable. And I hope that you are able to recall the formula for computing the variance from my previous lecture. The objective of estimation is to minimize the error and maximize the precision. Can we cut down the amount of estimation error, that is SST, and how? Yes, we can by using information about other variable suspected to be strongly related with the total number of credit card purchased by family. For example, family size, family income. On next slide, we will consider one more parameter, that is family size from our data set. So, from our US household sample data set, there is total 2 members belong to family number 1, which holds 4 credit cards. Remember that our objective in estimation is to minimize the error and maximize the precision. For that purpose, we are taking this one more parameter under the consideration. We can attempt to estimate total number of credit cards from the information on family size rather than from its own mean. On the next slide, we will consider this point on the plan in which we will put family size on x-axis and number of credit cards on y-axis. Let's see this graphically. So here we are plotting the actual number of credit cards against the family size. We know that y is a dependent variable and x is the independent variable. Question is that does the mean, that is y hat, appears to represent the closest estimate of the actual total number of credit cards for our sample families? That is, the green line represent the location of estimate of total number of credit card for these families. On the next slide, we will address this question. Linear regression finds the straight line called the population regression line that best represent the observation in bivariate data set. We know that y is dependent variable and x is an independent variable. The population regression line is y is equal to a plus bx, where a is a regression constant and b is the regression coefficient. X is the value of independent variable and y is the predicted value of the dependent variable. There are certain properties of regression line, such as the line should minimize the sum of the squared differences between the observed value, that is y, and predicted value, that is y hat. Another property, such as regression line should passes through the mean of x values and through the mean of y values. There are few more properties, but right now we should interested in a regression line. So we are just trying to find what exactly the regression line. So the regression line, that is the dark blue line, is a best fitting line through the observed data point that are intercept on y-axis. Okay, so slope of the regression line, it shows how much y changes for x value. Next, we will see the estimation error between the actual data points and estimated data points. Here you will see the difference between the red dots and the blue dots. The red dot indicates the value of mean estimation, and the blue dot which shows the value of mean squared, which intercept on best fit regression line with a new improved location for the credit card estimation. The sum of the square error is a simple straightforward method to fit intercept line between this point and compare those lines to find out the best fit through error reduction. The error are the sum of the difference between the actual value and the predicted value. At this moment, we have not calculated the value of A, that is a regression constant, and value of B, that is regression coefficient. So let's see what is the way to calculate it on the next slide. If you recall from the elementary algebra the equation for a line, you might also recognize the equation as the slope formula. The equation has a form y is equal to a plus bx, where y is the dependent variable, that is variable that goes on y-axis, and x is the independent variable that is plotted on x-axis. B is the slope of the line and A is the y-intercept. The first step in finding the linear regression equation is to determine if there is a relationship between the two variables. This is often a judgment. So let's calculate the value of B, that is the slope of the line. So B is the sum of the difference between x minus mean value of x, that is the x bar, into y minus mean value of y, that is y bar, to sum of the x minus x bar square. While to calculate A, that is the y-intercept, we need the difference between the mean value of y, that is y bar, and minus slope coefficient into a mean of x. To calculate the value of A and B, it will be better to put the required value into the one tabular format for better understanding. So on the next slide, we will see the tabular format. We need to calculate the value of x bar, y bar, then sum of the difference between the mean value of x, and at the end we will take square of it. So we already calculate the value of y bar, that is total number of actual credit cards to the number of families. So it equal to 7. Now next is x mean. X mean is the sum of the families of the size divided by total number of families in a sample population, and it is equal to 4.25. Next we will subtract the value. So just we calculated the difference between each x and the average value of x. Now we are able to proceed to calculate the sum of the difference. So the sum of the differences is 17, and the square difference is 17.5. Now we can easily able to calculate the value of A and B, that is coefficient of regression constant and the slope coefficient. Here we put the calculated values in equation of B, that is the regression coefficient. So it is 17.5, that is 0.97. We know the value of B, so we put in A, that is y-intercept. So it can be calculated as estimated total mean of credit cards 7 minus value of B, that is 0.97, into mean value of family size, that is 4.25. So we got 2.87. Regression coefficients are estimate of the unknown population parameter and describe the relationship between predicted variable and response variable. In the linear regression, coefficients are the values that are multiply the predictor value. Suppose you have the following regression equation: y is equal to 2.87 plus 0.97x. In this equation, 0.97 is the coefficient of x and it is a predictor, and 2.87 is a constant. The sign of each coefficient indicates the direction of relationship between a predictor variable and the response variable. A positive sign indicates that as the predictor variable increases, the response variable also increases. Here it is not a case, but suppose A is having a negative sign, then indicates that as the predictor variable increases, the response variable decreases. Now we will be able to draw a new improved estimated regression line. So next we can see estimated regression line. Now you can examine the difference between our household's actual total number of credit cards and their new regression estimation. That is explained by the differences in family size. Further, we can improve this result by considering family income as one more independent parameter. We can summarize the steps involved in simple regression analysis in such a way that, suppose if you remember, then we first calculate the average of x variable, then in second step we calculate the difference between each x and the average x. After that, in step number 3 we square the differences and add it, that is we calculate the sum of the square for each pair of the observations of x and y. Finally, in step number 4 we carried out the same step to calculate the average of your y variable. So the are suitable only for solving the problem by hand. If you are using R or computer programming to solve the regression problem, then you need to import ggplot library to display the scatter plot. Now let's summarize our today's session. In this session we learn how dependent and independent variable shows a linear relationship between the slope and the intercept. We had learned basic fundamentals associated with regression analysis. We have also described the importance of error estimation in regression analysis. We saw that the value of the residual was constant across all observation. We reviewed an example based on a simple linear regression. If you have any query or difficulty regarding the regression analysis, feel free to post your queries on the forum Google Classroom. Following are some important questions that were asked in SPPU in same examination as well as in end same examination. So you have to take it as an assignment question and submit it to our Google Classroom. So the first question is that is asked for the 6th mark in August 2000 in semester examination. Explain linear regression with some use case. Then another question that was asked in August 2018 end same examination. The question was asked for the 8th mark, such as enlist the types of regression analysis and explain simple linear regression with example. So these are certain references. You can learn the basic fundamentals of regression analysis from this URL. In the next session, we will discuss the example based on linear regression and multiple linear regression from the module number 2, that is validation and testing. We will learn predictive model building using regression techniques such as linear regression. You can revise the fundamentals associated with linear regression and multiple linear regression from our reference book, that is Data Science and Big Data Analytics. Thank you very much. Have a nice day.